All right, so Alex was not able to come to the second or to today's course, but he was in the main section earlier today. And plugging OS2G, that's Operating Systems and Open Source Group, and that's a recognized student organization that's over 10 years old or so. They focus on open software, Linux kind of stuff. They have technical talks. For example, last year they brought in somebody to give a tutorial on advanced Git stuff. You've been using Git, and hopefully you're picking up more and more as you go along. But if you ever want to do more complicated stuff like merging resolutions, branching, stuff like that, that's a good group to talk to. You can go ahead and join the Discord. Also, there's a club membership, or there's a website, os2g.club. And they are having an event this coming Thursday, February 6th, or February 5th, excuse me, from 6 to 8 p.m. They've got several Raspberry Pi Zeros, and they're going to show you how to install Linux. If you want to, you can go ahead and bring your own computer, and you can install Linux there. Dual boot it is what I would do, so that you're not, just stuck with one or the other, so that you can try it out. But if you want, usually Linux user groups like this, they have install fests or install-a-thons. Also, Raspberry Pi. I don't know what version of Linux they're installing, but you could always install like an image of what is it? RetroPie. That's it. Have you ever heard of RetroPie? No, it's you can play if you've got all the ROMs for it. You can play all the old classic and modern video games. No, all right. So try it out. Go there and visit, and you can try it out. And you don't have to bring anything if you don't want to. You can just sit and hang out. But that is another student organization that has a lot of members and is very active. All right. So we were going to transition over to Java and in particular object-oriented programming. And the way that I wanted to start was by reviewing what we did last semester, by taking what we did this semester in the main section and just reviewing and then extending what we did. Basically, you can ignore most of this stuff. It's going to be very much like what we did in Python. We've created a book class here to represent a book because we want to take these pieces of data and we want to collect them together into one logical unit. That's what encapsulation is. We've got a book ID, author, title, author. We immediately went and decided that, wait a second, we want the author to be a person here, right? Because that first name, last name, that's a person thing. Where does it belong? It belongs in the person class. Anytime you have a design question of where does this thing belong, right? Well, what is it? Oh, it's an account thing. Then it belongs in the account class. It's a book thing. It belongs in the book class. It's a person thing. It belongs in the person class. Anytime you have more than one piece of data, in this case, first name and last name, then that should be screaming out to you, this probably belongs in some sort of a class here. All right? Now I added a whole bunch of bells and whistles here. Let's go ahead and start with the person class. It implements comparable. Now you remember we did this in Python by bringing in this, func tools, right? And then we defined the LT less than, and we defined the EQ equals method. That made it into a total order. That's what comparable is here, that you can take one person and you can compare them to another person. Now the way that works in Java is that you have to implement this compare to method, right? You don't just do a less than and the greater than or equals or something. You do it all. This compare to method returns an integer. That's going to return something negative, positive, or 0 depending on the relative ordering of those two things. It's going to compare this object to that object right there. If they have the same last name, then that will return 0. All I'm doing here is using the compare to method for a string. I'm comparing the last name, which is a string, to the person's last name, which is also a string. If they're not the same, right? Anderson and Zoe, right? Anderson comes first, right? You're done, and you return the result. Otherwise, if they have the same last name, then that will return 0. Remember, something positive, negative, or 0. Then we break that tie by looking at the first name. Right? Now, if there's still a tie after all of that, forget about say hello here for a second. If there's still a tie after all that, then so be it. They're the same person, right? Terry Pratchett is the same person as Terry Pratchett. Okay. Ignore that for a second. We'll come back to it. But objects in Java, objects in any object-oriented programming language, but also especially Java, they have to have identity. The way, if you're going to use objects in the collections data structures like array lists, hash sets, and hash maps, then you need to implement this hash code. You need to implement this equals method. It is not enough to say that they're comparable. You need to also say that that object is not the same thing as that object over there. Right? And the way that you do that is by implementing the equals method. First of all, it says, is this object equal to that object? Are they the same thing in memory? That's what this is doing. All right? If that's the case, then it returns true. They are the same object because they're occupying the exact same place in memory. Otherwise, if if that object is null and I am not, right, then that means that they can't possibly be the same because that one's null and this one's non-null. So we return false. If they're not even the same class, then they're definitely not the same object, right? If that is a string and that is a person, they're not the same thing, right? Apples to apples, oranges to oranges. Then finally, we compare the first name, and if that's equal, and if the last names are equal, then we return true, right? That's what this last line is doing here. No, I did not write most of this, right? In fact, I'll go ahead and get rid of that and remind you of some, I'll get rid of this stuff too, right? There we go. And remind you of how you can, speed up your development, right? This is not AI. All you need to do is go up to source. I want to generate that constructor using fields. There, it's done for you, right? Remember that a constructor is like the init function in Python. It'll initialize something. It takes the last name and the first name, and it uses the this keyword in this instead of the self. Oops. There is no self keyword in Java. That's a Python thing, right? Instead, it's this. This last name is equal to that last name. This first name is equal to that first name. Then what I had below was a bunch of getters, right? Oh, it disappeared. What happened to my? Okay, there. Now it reappeared. Weird. All right. Anyways, up to source. Generate getters and setters. Generally, you don't want to go with setters because that makes your objects mutable. So let's go ahead and just go with getters, and that generated the code right there. Done. Right? The toString method also, but was generated that way. And then finally, all that complex code for doing equals and hash code, I didn't write a single line of that. That was all generated by my IDE here. Okay, done. Right? So to speed up the development of the book class, all you need to do is define this stuff and then generate constructor using fields, generate the toString method, generate getters, et cetera, et cetera, et cetera. Right? Let's walk through this a little bit though. A book ID is going to be an integer. The title is a string. The author is a person. ISBN is also a string because sometimes ISBNs can have numbers in them or letters in them and hyphens. Right? The rating is a double. It's on a scale of 1 to 5 with partial increments. Right? The publisher is a string. The year is an integer. How did I represent the date? Right? Yeah, it's a local date. Right? It's a built-in object. I could have gone and created a new class here called date, right? New class, my date, right? And I could have represented that, say, as 3 integers: private int month, private int day. I'm not even going to complete this. Why? Because again, in engineering, what's the first question you should ask yourself? Is it already done? And yes, it's already done. Local date. Why is it local? Is it the same day everywhere on the face of the earth? No. It's localized to wherever your time zone is, right? And so that's why it's local. If you just had the like a date, when and where is it, right? And so it's localized, okay? There's my constructor using an author. We'll come back to that maybe later on. But otherwise, there's everything else. There's the other constructor. Here's a nicely formatted string. So what is string.format? That's like sprintf in C, right? Instead of printing the standard output printf, you are printing to a string because you need to return that string here. Then I've got a bunch of getters. What else do I have? And that's pretty much it. I did have a setter here that I demonstrated to the other class, but again, we like our objects to be immutable. Once they're created, they cannot be changed, right? Because that makes it thread safe automatically. All right. I also wrote this function in the other class. We wrote it together, but I'm speed running this for the H section here to load book data up from that same file that we were working with. I create a file. I want to read it line by line, so I create a string called line. I create a list of books, which is an array list that I'm eventually going to add each book to. A scanner is how you do file input. You scan the file instead of scanning the standard input. Now, I'm burning the first line just like we did in Python because that's the header data, right? And then for each line after that, I get the line, I tokenize it using split, just like I did in Python. I grab each one of those tokens, convert them over to what they need to be, and then I create a book. And by the way that you create local dates is you call a constructor on it, you call parse, and then you have to give it a formatter, right? And the formatter in this case is going to be the incorrect American way of doing it of month with no leading zeros, day with no leading zeros, and then the year with forward slashes, backslashes. Okay. Forward slashes because you're facing right and you are leaning forward, right? It would be backslashes if you were leaning backwards, right? So there's the improper American way of doing it. The only proper way is the ISO 8601 format, which you do not need a formatter at all for that because that's the default in computing, right? All right, and it's also the default in your project when you eventually get to it because I'm not going to make a weird formatter for you. Anyway, after we're done reading the file, we close our resources, and then we return. So that's where I'll pick it up from here. Let's redo all those reports that we did before, but let's do it in Java. What is the oldest book and what is the newest book? Having seen how we already did this in Python, what is your very first instinct? Let's sort it. Collections.sort books. That won't compile. If it were a built-in type, an integer, a string, a double, it knows how to sort those things because they're all built to be comparable, just like my person class was. Right? But my book class was not built to be comparable. Right? So I need to provide it another thing. Right? What is that other thing? It knows how to sort. It doesn't know how to order, though. Here's a book. Here's a book. All right? I want to order them by the year that they were published. So how am I going to go about doing that? What's that other component there? In C, it would be a comparator function. In Python, it would be like that lambda, which is basically a comparator, right? And over here in Java, it's going to be a comparator class, right? CMP by year. Now, how do I create comparators in Java? Here's how the old school way of doing it. A new comparator for books, right? Actually, I should have put that over here. Book, right? And then I don't have to put it over here, right? There we go. That's the better way. That's the more modern Java way of doing it. And then I immediately define what it is, right? So let me go ahead and hover over that, add unimplemented method. Compare. It returns an integer. The contract there is something negative, positive, or zero, depending on the relative ordering of those things. Exactly the same thing as in C, exactly the same thing as in Python, and I can almost guarantee you exactly the same pattern as any programming language that you're ever going to use, right? All right, I don't like O1 and O2. Let's call it B1 and B2, right? How do I compare those books if I want it by year? Right? Well, I have to extract the year. B1.getYear, right? Compare to B2.getYear, right? And I would need a not complex logic, but I should do something like this. If B1's year is less than B2's year, then are they in order or out of order? Do you want to go in ascending order or descending order? Ascending, because that's usually how you do it, right? So this means that they are in order. So I return something negative. Don't get fancy. Don't get 42 on me, right? Don't get Douglas Adams, right? Just ones and zeros are fine, right? Else if, right? It's the other way around. That means that they are out of order, in which case I return something positive. What's the only other possibility here? They're the same, and you return 0. Once I've got that comparator, I can now use that in my sort, right? And now it knows how to do it. Right? Before we actually answer the questions, let's go ahead and print them out. For book B in the collection books, system.out.println B. Right? Because I overrode the toString method, just like in Python, the str or the repr method, right? It takes care of all those details for me. I don't have to rip its guts out and then print it out. There we go. Anne of Green Gables, Tropic of Cancer, all the way down to Raising Steam by Pratchett. Okay. Is that in order? 1908, 1934, ... all the way up to, what's the most recent? Raising Steam. Right. It's a different data set than we were doing, by the way, right? 2013. Is that in order according to the year? Looks like it to me. So now we can answer those questions. What is what is the oldest book I've read? What is the youngest book I've read? What is the most recent book I've read? Newest book. So book, oldest book, is equal to what? And book, newest book, is equal to what? Well, where's the oldest book? It's right at the start. You can do an index-based one or books. How do I get the last one? Get last. And yes, there is a get first. Let me update that. Get first. There we go. And let's print those out. All right. System.out.println oldest book. And I'll just concatenate it. Oldest book. There we go. And then the newest book. Did I spell everything correct? Hopefully. I mean, it's weird because it's lining up. And okay, yeah, newest. All right. Raising Steam by Pratchett, 2013. All right. How would you go about doing the best work, best and the worst book? Same pattern, except that I'm going to show you a much more compact way of doing it. Right. So let me grab that. And let's go ahead and create a comparator, not by year, but by rating. And I'm going to do it the easy way. Pairing book get rating. Done. Right? So this, do you remember this syntax? Or this might be new syntax if you have Java already. This is the class, and then this is the method selector operator. It's very old. It actually comes from C++, and C++ took it, I believe, from maybe Fortran. But : selects that function right there. Comparator, I'm going to create a comparator comparing the get rating. Right? Now let me print it out to make sure that it's in order of the rating for book B. Shouldn't have gotten rid of that. So I didn't, did I? All right, fine, we'll write it again. In books, system.out.println B. So I've got the first two done. What about the there? Are they in year order according to the year anymore? Definitely not. Right? I need to clear this. Am I printing somewhere? I shouldn't be printing anywhere other than here. Okay, there we go. Now that's clean. There, go up to the top there. All right, so Anne of Green Gables is the oldest book. It's still an oldest, youngest. Oh, that's why. Have I actually sorted it yet? I just created the comparator. Collections dot sort books CMP by rating. There we go. Forgot to do that. Collections dot sort. There we go. Run that again. There. Twice Upon a Time has a rating of only 3. Lowest rating there. And then the highest rating is down here. Wise Man's Fear 4.455. They are indeed order. I don't like that though. I like the best books at the top, right? That seems more natural to me, right? Quote unquote. So how do I do that? Well, in Python, I did the little trick of just negating everything. I can't do that here. Instead, I go reversed. I chain them together. This, comparing that, comparing, and then you can also reverse it. And now the best book is going to be at the top, which is Patrick Rothfuss's Wise Man's Fear. Right? I wouldn't agree with that, but whatever. Right? Yeah. Folks on Goodreads that are really into fantasy books are really into fantasy books. So everything is a 5-star, right? So what is the, I won't even bother pulling out the best and the worst. We know how to do this now, right? Okay. Find a book by Frank Herbert. A book. Not all the books, but a book, right? So I could go through, a traditional, for loop and do linear search and say, is that it? No. Is that it? No. Is that it? No. But let's do the same thing that we've been doing here. Let's sort it by author, and then if it's sorted by author, what kind of search can I exploit now? If it's sorted to be much faster, binary search, right? All right, we couldn't do that in Python. Why? Because Python doesn't care about binary search because Python, everything is hash-based. So they want you to use it as a hash-based data structure rather than an array because there are no arrays, right? So my first thing is to create a key. Person Frank is equal to new person I think it's Herbert, comma Frank. Last name, first name, is it? Let's come back over here and just, oh, and remember this is Eclipse, by the way, if you're not familiar with it. Go through the first lab, the Java version, there's a full walkthrough video. I go through all these tricks, like you can bring this over here, just like we did in the CS50 IDE. It is indeed last name, first name. I don't need that anymore. All right, there's Frank. Is that my actual key though? All right. So let's try comparator. Let's create a comparator by author, and then sort it by author. Right? By author. Right? Now, how are you going to sort it by author? Well, get author. Right? That only works because of the design that we went with before. Let me show you what I mean by that. All right. Remember I said that I made this comparable? What if we did not make that comparable? Now Java does not know what you're talking about. Right? As an author, how do I compare that author to that author? You haven't said, right? You haven't made that class comparable. Once you make it comparable, then Java can say, yeah, I can compare those two things. Right? I just call that function that you wrote in that class. And then let's go ahead and sort by it. Right? And we can print it out again. Did I get rid of this? Dang it. All right, I should have just put that into a function, right? So I didn't have to rewrite it every single time. For book B in the collection books, system.out.println B. Right? Let's just make sure that this sorting is actually working, that it's by author, last name, first name. At the top, we have Anderson, Paul, right? Armstrong, Asimov, ... And then down at the bottom, we have Yang, right? So does that look like it's in order? Yep. What about, say, books where we have the same author? Are those necessarily in any order? Like, the, of course, would be in there, but does wise come before name, or does name come before wise? Probably the name should come before the wise, right? So let's go ahead and change this so that we're comparing that by author, then comparing the book's title, or get title. Right? You can chain as many of these things as you want together. And then if you want to, you can reverse it. Right? I'm not going to do that, but dot reverse. Right? You can chain all those together. Right? You don't have to write all the code. You can just chain those together, and it's good. Now let's take a look at Patrick Rothfuss here. Rothfuss. There we go. Now, all the authors are together, but then if you've got the same author, Patrick Rothfuss and Patrick Rothfuss, now the titles are in order. Okay? What if they had the same title? Same book, same title, different editions? Maybe you'd go to the ISBN or something like that, right? Ultimately, though, if you want to break ties, you need to find something that is guaranteed to be unique. And at least with this data, ISBNs are guaranteed to be unique, but even more unique is going to be a book ID, because that's being pulled from the database. All right. Now that I have it sorted by author and title, right? I actually introduced a bug here. We're going to fix it in a second. Let's go ahead and find a book by Frank Herbert here. So collections.binary search. Right? That will return an index at which it found it. That index will be negative if it doesn't find it. Right? So you can check for it. Let's go ahead and search the books for Frank, and we're going to need to use the same comparator. Right? If you don't use the same comparator, by the way, right, then what's going to happen? What if it was integers and it was sorted in ascending order, but then you used a comparator that was in descending order? You start going the wrong direction. Right? All right, so there's binary search. It's not going to compile. That's another issue that we'll come back here in a second. If index is greater than or equal to 0, then that means we found somebody. We found a book by that author. Let's print it out. System.out.println books.get, whatever that index tells us. Else system.out.println no such book by that author. Okay, and we can come back and change the author if we want to. Problem number 1, it is not compiling. If you're going to search a bin of apples, your key needs to be an apple. Apples to apples. If you're going to search a bin of oranges, your key needs to be in orange. What is my key here? Frank. It's a person. What is my haystack? Bunch of books. Apples and oranges. I need my key to also be a book. Book, Frank, key is equal to new book, Frank. And that's why I had two constructors. You can go ahead and construct books using all of these pieces of data, or you can construct a book because you want to search by author. All you need to provide me is the author. That's why I had two constructors there. The first constructor only takes an author. The second constructor takes everything. Add as many constructors as you want. There is no limit, right? We'll get to best practices later on, though. Okay. All right. So this is going to be Frank key. There you go. Now it's apples to apples, oranges to oranges. It probably still will not work. Yep. Cannot read field value because another string is null. What? So this is not going to help all that much. But you can kind of read this. Comparing, then comparing. There was something wrong with then comparing. What does my comparator actually do? It compares an author, and then if it's the same author, it compares the title. Is my book here, that just as an author, is that going to have a title? Nope, it's a dummy key. So I need to get rid of this. If you're searching by purely by author, then your comparator needs to be a pure author comparator. Okay? And now this should work. That was the bug that I introduced. There we go. There. The White Plague by Frank Herbert. That's just a book. I think that there are like 6 books in there by him. And that takes us to the last question. Right? Who is the author whom I've read the most, at least according to this data? Okay. I don't think that we quite finished that part in Python. We got almost there by creating a map, a dictionary of authors to their list of books. Let's do the same thing here. Right? Create a map of authors, author to list of their books. Okay. Now we don't have dictionaries in Python. Instead, we have something much better. We have maps, right? Maps can map whatever you want to whatever you want. In Python, they're kind of limited because dictionaries, you can only use integers and strings as your keys, unless you bring in a library to do it and make it hashable. If you make anything hashable, there's some tricks that you have to do, so you can get the same effects, but it's going to be a little bit more work in Python. In this case, I want to map an author, which is a person, to a list of their books. Right? And there's my book map is equal to new hash map. Okay. You can put whatever you like within this Langle Wrangle. That's left angle bracket, right angle bracket, right? Including something that is also parameterized, a list here of books. And by the way, if you want the full version of this demonstration, just go ahead and watch the main sections videos over the last week. We built all this stuff up iteratively over 3 lectures instead of throwing it at you in 1 lecture here. Right? Or if you did it last semester in 155H. Right? Okay, I want a book map here. Ideas. For each book, how did we do it in Python? For each book B in the collection books, okay, I'm going to get the author. Let's extract the author just so that we can deal with the author here. B.getAuthor, okay? Now, I want to look in this book map for the author's current books, list of books and books. Actually, I can't use books again, can I? Author books, there we go, is equal to book map dot get the author, okay? And then once I've got their books, I can just add it, right? Author books dot add B, okay? This is actually going to crash with a null pointer exception. Why? Did I ever create any actual lists? No. Right? So what happens if this is the first time I've seen this author? What is this book map going to return? It's going to end up returning null. Right? So the first time we see him, we need to create that list. Right? if author books is null, right, then I will say author books is equal to new array list. There, now I created it. I add it. Oh, but did I ever actually put it into the map? Let me show you that I didn't. Let's go ahead and go with system.out.print. I'd love that if there was a pprint here, but there's not. Sorry. Println book map. At the end of the day, I mean, this is going to run probably with no exceptions, but it's going to end up printing nothing in my map. It's an empty map. Right? So what else should I do beyond creating it? Bookmap.put. I'm going to map the author to their author books. There. Oops. Cut. And now it's going to be one big giant. Isaac Asimov indeed wrote Pebble in the Sky. Gordon Dickinson wrote Dorsai, et cetera, et cetera, et cetera. That ain't pretty though, is it? So, is there a pretty print in Java? Maybe bring in a library to do it, but it's easy enough to go ahead and write a for loop. For person author in the collection book map, right? I will system.out.println the author, and then I will get all their books. Oh, it's not book map, it's their keys, .key set. In Python, if you just iterate in a for loop over a dictionary, it'll automatically do it all the keys for you. You actually have to invoke the key set on this one. Okay? And then for book B in the collection bookmap.get author. In other words, for all the author's books, system.out.println, and let's tab over so it looks nice, B. Okay? And I'm going to go ahead and get rid of this other printing up here, just so that it looks nicer. There we go. All right. Here's another trick. You can double click any tab and expand it out. Double click it again and it goes back to normal. Let's go ahead and take a look here. Right. Isaac Asimov only wrote one book according to the data that I have right now. But Kurt Vonnegut there, he's got 2. Right? Ooh, Carl Hyacin, he's got 1, 2, 3, 4, 5, 6 in my collection here. Et cetera, et cetera, et cetera. Right? Ooh, Frank L. Baum, he's got 12 Oz books right there. Okay. So, but I want to answer this question. It's probably going to be Frank L. Baum, but I want to answer this question programmatically. Right? Now that I've got my data organized like this, how do I find the most frequent author? Right? I need to find the largest collection in my book sets. Right? Okay. So, ideas? I could iterate over the values, right? For list of books, book list in the collection bookmap.get value or values. There we go. And then I could keep a track of the largest one, int largest. Actually, let's go ahead and put it into a list here. Right. Largest book list, and then if book list dot size is size, thanks for the code completion there, is greater than the largest book list dot size. And by the way, I'm going to have to initialize that. So bookmap dot values dot first dot get old school iterator dot next. I'll come back to that, but that's how I have to do it though, because it's a set. Then we'll say that the largest book list is now equal to the book list. And then we can print that out, system.out.println largest book list. There. And it's going to print out there, all by Frank L. Baum. You could go ahead and get the author dot get. Let's go get the first book and then get author, and then you've got your answer in the end. Frank L. Baum, right? Just like I suspected. Is there another way though? I mean, you could do this. Well, once you get used to using maps, you want to use them for everything. I want to use it for this too. What if I had a map that mapped a person to the number of books that they've written? Right? Book count is equal to new hash map. Okay? Now, why does that help me? All I need to do is iterate over this again, right? And I don't even need to iterate over the books anymore. What should I do? Book count dot put author maps to book map dot get their author's books dot size. There. Now let's print that out in a nicely formatted manner. Once again, I will steal this thing here. Let's steal this. And author, and then plus a colon plus not that book count. There we go. Book count dot get author. There. What's the data going to look like now? It's going to be the author mapping to an integer here, like Jack Vance there, 4. Diane Wynne Jones, 2, right? What else is in there? There, Frank Herbert, he's got 6. The 5 Dune books plus the White Plague there, right? All right. Also a great author there, right? Okay. Well, if I've got all those numbers, then what do I have to? Now all I have to do is what? Get the minimum. And do you remember we did min and max in Python? There is a min and max here. Collections.min, or let's go max, max of the book count dot values. There. System.out.println max value is going to be plus what? Oh, I should have saved it. There we go. Int max is equal to, and then max. Remember, it was Frank L. Baum, right? How many books did he have? 14, apparently. Right? Okay. But does that tell me who it is? All right. Darn it. So then, if this were Python, what I could do is I could say, give me the key and the value where the value is equal to 14 at that point, right? In a list comprehension, and then I could just get that one value, right? There's not as nice syntax over here in Java. In fact, it's ugly a syntax that I'm not even going to bother doing. But you could iterate over them all again and find that one person, right? If that book count dot get author is equal to the max, then print out the person. There. Okay. There, max value, and then Frank L. Baum with 14. Now, is that guaranteed to be unique, by the way? What if there were another author with 14 books in there? Then it would print them both out. Okay. That's really that's a key realization that you'll eventually have in, say, 235 when you get to what are things called relations and functions. You already know what functions are, right? What is a function? It's a mapping from a domain to a, sometimes you call it range, but we actually call it a codomain. The range is the thing that the smaller stuff is the subset that it actually gets mapped to. There might be some things that are not mapped at all, right? A function works only one way. Unless it's an invertible function, right? That is, you can have one value mapping to one thing over here. You can have another value mapping to the same thing over here, but you can never have two values, or you can never have one value that maps to two things. Why? What's the classic example? The unit circle. Why is the unit circle not a function? Because of the vertical line test. You have an x that maps to a positive value and a negative value down here. That ain't a function, right? But it is a relation, right? And that's what you'll get into in 235. A map is a function because it only works one way. It doesn't work the other way. 14 and 14 maps over here, right? Technically it's a function, but it's not a one-to-one function, right? You'll get to all that. One-to-one, injective, surjective, onto, all that stuff. All right, and then you'll have a greater appreciation for data structures like this, because you'll see this immediately and say, oh, that's a function, but it's not a one-to-one function, right? All right. Any questions on that? Otherwise, you can also get the code in the main section's repository. It's right next to yours, right? Where we've been posting code. All right, so a little bit more formal here now, right? Java is a class-based object-oriented programming language. Now, you might think, well, coming from a C background, we have structures. Structures aren't objects. Structures are only data containers. Coming from a Python background, you might think, well, is Python an object-oriented programming language? It has classes. It ain't an object-oriented programming language. It's had object-oriented programming features added to it over the years. It didn't used to have classes, but now it does, because people demand the classes, right? And in Java, everything is a class or belongs to a class. And by the way, there are object-oriented programming languages out there that are not class-based. The only one that I can think of, however, is JavaScript. JavaScript, but they added classes too many years ago. They started out as a non-class-based object-oriented programming language. They did everything ex nihilo, which is Latin for from nothing. Don't worry about it, right? Anyway, everything in Java is a class or belongs to a class. That's the consequence. Is that true in C? No, you can have a function that doesn't belong to a class because we don't have classes. You can have a variable that doesn't even belong to a function, right? They're called globals and they're evil and you shouldn't do them, right? Or you can have constants in the math library. That's fine, right? But otherwise, in Java, everything has to be a class or has to be inside of a class. Right? A class in Java allows you to model a real-world object, entity, or idea. In this particular case, we've done book. We've done person. If you were doing the third exercise in Java, you would probably want to create a class called transaction, right? Because you want to model that, okay? What are all of these objects, right? Formally, an object is an entity characterized by three things, okay? And you might recognize these things from encapsulation, but let's zoom in a little bit. There we go, all right. First of all, identity. You have to have an aspect of an object that distinguishes it from all other objects, right? For example, if I just had a string and I used equals equals, is that necessarily going to say that these two strings are equal? If it's apple and apple, it'll return false, right? How do we achieve that in Java? Well, we achieve it through an equals method, right? Auto-generated, of course. It has state. That is the collection of properties, elements, attributes, data, field. We call these member variables, right? That define the state of the object. Well, what's the state of an object for the person? Just two objects, or two other objects, which are last name and first name, which are strings. What's the state of a book? Well, it's these, however many of these things are. 1, 2, 3, 4, 5, 6, these 8 pieces of data here, right? That's the object's state. What is its behavior? That's the functionality that acts on the object's data. What does the object do, or what services does it provide? In other words, at the end of the day, it's methods, right? So we've kept this pretty simple up till now. Book, right? These two things are constructors. That is part of its public interface. A toString method, getters, right? All of those are pretty much standard for anything that you design, right? But you can also have other methods. For example, person. Where was it? Oh, I got rid of it. Okay. We can have another function here called say hello. Let me make it private at first. Private void say hello. Right? And I'll say system.out.println hello, I'm, and then I'll put plus first name. There we go. There's something that is completely unique, right? Or that is completely different from the getters, the setters, etc. Right? It's a kind of a stupid function for now, but bear with me, right? Let me go over to demo here, and yeah, let's go ahead and get rid of this. If you're interested in that, you can also watch the earlier live stream. Let me go ahead and create two people now. Person John is equal to new person, Smith, comma, John. Right? And if I called that function John dot say hello, or no, not equals, dot say hello, right? Then he would say hello. It's not compiling though. Why? Private. Right? You can have private methods, and sometimes you want private methods, but it's no longer part of the behavior because you can't even see it. Right? It's no longer part of what's called the public interface, how you interface with this object. So let me make it public again. Right? Come over here to my demo, and hey, now John can say hello. Hello, I'm John. Right? If I created a different person, Jane, would she say the same thing? Did I write another function, by the way, called say hello? No, there's one function called say hello, but it does different things. Why? Oh, I need to go with Jane dot say hello. Right. There's one say hello function, but it belongs to two different instances. One of them says John because he's John. One of them says Jane because she's Jane. Right? But there's only ever one say hello function here, right? Say hello and say hello. It's the same exact function. Right? But it acts on different data. This object, now John is one object over here, Jane is one object over here. I am sending a message to each one of those to invoke your say hello function. When it happens, it says, oh, okay, John grabs his first name and outputs it. Jane grabs her first name and outputs it, right? It's much different than what we've been doing up to this point. Math dot square root, right? Is there any state to that square root function? Square root of 2. Let's check it out. Right? Strict math calls another function, calls another function. There we go. Right? It only ever takes input, right? Because it is a static function, right? Is there any data on it for it to act on other than x? And by the way, it is really complicated for square root, right? But it turns out that that's, oh wow, how many, 16, 12, and that's going to be what? Normalize it up to, so over 100 lines of code to do the square root, if you've ever wondered how it works, right? But there is no state other than the state that you give it to invoke, right? So those are the three things that make an object, that make a class in Java. And we'll talk more about that on Wednesday when we come back, because on Monday when we come back, we'll be talking about technical writing and what you need to do for your first draft of your design document, all right? Eventually, it's going to be like 10 pages. The first one is not going to be 10 pages, okay? What we're expecting you to do is to outline what the project is about to prove that you've read the handout, right? And that's what we'll talk about how to go about technical writing on Monday. Have a good weekend.